Hello students, today we are going to study polynomials for class 9, that is chapter 2 from NCERT book. Okay, so let us look at the following word, polynomial. So what does the word polynomial mean? Polynomial means, poly means many and nomial means terms. So when we deal with one or more terms which are of algebraic nature, we call them polynomials. Okay. So terms. What are terms? Term is like 4x square. Okay. 2xy. 4zx. So a term is made up of coefficient and variables. So similarly, let us first understand what is a variable. Variable is, it can be any non-numeric expression or non-numeric symbol like x, y, z, a, b, c, anything that is not a number. That part is called as a variable where we can put the value. So variable is like a box where you can put something. Okay. So later on we'll see what value we are going to put and all. So 2xy here is a term. Okay. Now similarly, what is a coefficient? Now in the term, the number part, the numeric part which is written in the front is known as a coefficient. Okay. So in this case 4 is the coefficient, 2 is the coefficient, 4 is the coefficient, and what are the variables? In this case x is the variable, here x and y are the variables, here z and x are the variables. Now if you ask me minus 4xy, in this case the coefficient would be minus 4. Okay. So we know what is a term. A term is made up of variables and coefficients. Okay. And variables are the um, expressions where x, y, z, these variables are there. Coefficient is the one that is in front of the variable. Okay. If we combine them, 4x square plus 4xy minus 4zx minus 4xy, all these combine to make a polynomial. Okay. And what is a constant? The one which does not have a variable attached to it. For example, I write 2x plus 7. In this case, 2x is a term, 7 is also a term. 2 is the coefficient, x is the variable. 7 does not have any variable attached to it. So 7 in this case is a constant. Let us look at this particular example. Here 7 is a coefficient, 4 is a coefficient, 3 is a coefficient. Okay. X square, actually x, it's a variable. X is also a variable. Now in this case, 3 does not have any variable attached to it. So 3 is constant. Okay. 7 and 4 are coefficients. X is the variable. Okay. And 7x square, that is called a term. 4x is another term. 3 is another term. All these terms combine to make algebraic expression. Or we can also call it as polynomial. So we are clear with this basic concept? Okay. Now, this is very important part. Classification of polynomial on basis of terms, variables or degree. Now, classification on basis of terms, we can call it as monomial if there is only one term. For example, 4x or 4xy. There is only one term. In binomial, say 4xy plus 7z. So there are two terms involved. So this kind of polynomial will be known as binomial because there are two terms. For trinomial, say 2x square plus 7x plus 5. This is a trinomial. So monomial, binomial, trinomial. So how we are classifying? Based on the number of terms. The second way of classifying a polynomial is on basis of the variables. If there is only one variable involved in the polynomial, it is known as polynomial in one variable. Let us take an example, 2x square plus 5x plus 7. How many variables are here? X and x only. Okay, so this is known as polynomial in one variable, and we call it in short as this p of x, where x is the input. So the number of variables which are the input for this is is written over here. Okay, so if there were two variables involved, let us take another example over here. Say 2xy plus 7x plus 3. In this case, there are two variables involved. X is there, y is there. So here we will write it as p of x comma y. Got it? And if there are three variables involved, suppose 2x plus 3y plus 7z, 7xz. So in this case, the polynomial is dependent on three variables, x comma y comma z. Got it? So in class 9 chapter 2 we are going to study only this polynomial in one variable. Okay, we are not going to study here this one, we are not going to study this one. Okay, now based on the degree, now what is a degree? Let us have a look over here. This thing is also known as the exponent. Okay, so here the highest power is 2, here the power is 1. Okay, in this case it's 1 1 each. So when the highest power or exponent is there in a particular polynomial in one variable, then that particular one is known as the degree. So when the degree is 1, means say 2x plus 7, what is the highest power over here or exponent over here? 1. So 1 is the degree of this polynomial. So it is known as linear polynomial. Where did we come across linear polynomial? When we were in class 7 doing linear equations. Okay, in class 8 also we came across them. Now degree 2, example is 2x square plus 7x plus 5. In this case the highest exponent or power is 2, so the degree will be 2. We came across this in class 8 in form of quadratic polynomial when we are doing factorization chapter. Now degree 3, 3x cube plus 7x square plus 3x plus 2. In this case the highest power or exponent is 3. Okay, so the degree would be 3. So these are known as cubic polynomials. So the last one is degree 0. Degree 0 means it's a constant polynomial. For example, if I had written only 5, okay, or 2, what happens in these cases? The degree in this case is x to the power 0 actually. Okay, x to the power 0 means 1. So 5 into 1 is 5. So here the dependent variables are not here, like the variables are not there at all. So that's why these kind of constants are known as constant polynomials. Now as per class 9, let us look at those conditions that we need to satisfy for calling it as a polynomial in one variable. First thing, there should be only one variable involved. Okay, anything more than one variable does not call it as a polynomial in one variable. Okay, that is very simple one. For example, this one, x to the power 10, y to the power 3, t to the power 50. There are three variables involved, so this does not satisfy the condition to become a polynomial in one variable. Okay, let us look at the second one, y plus 2 by y. So here there is only one variable, so will it be called polynomial in one variable? Let us look at the second condition. The exponent should be a whole number. Okay, so in this case the exponent is 1, in this case the exponent is 1, but there is a slight problem, it's in denominator. So actually the exponent would be written this way, class 8, this thing, y to the power minus 1. Minus 1 is a whole number? No, it's not. So it will not be called polynomial in one variable. Okay. Now let us look at the third one. There is only one variable involved and the degree is 2. This is 1. So overall it satisfies both the condition. So this satisfies the condition for polynomial in one variable. So are we clear with this? So chapter 1 2.1 actually talks about these conditions. Okay. Now, what is value of a polynomial? as I had told you, what was px? Px, where x is the input, like input as in what value we can put for x so that we get overall value for this expression, okay, or rather the polynomial. So when I take x equal to 2, so how can I write this as p of 2, 2 to the power 2 plus 2 into 2 plus 6. This would be 4 plus 4 plus 6. So 8 plus 6, that is 14. So the value of this polynomial would be 14 when x is 2. Okay. So when x equal to 2, p of 2 will be equal to 14. So in chapter 2.2 we have these kind of things where you put a value and you have to see what values you are going to get for the polynomial. So this part is clear. Now what is zeros of a polynomial? Zeros of polynomial is nothing to be scared of. Basically, we have to find one such value. In this case, I'm saying it as a, such that putting that in the expression, we end up getting the overall value of the polynomial to be 0. Okay. Now let us check if by giving this value x equal to 2 is a 0 of polynomial, this one. So we'll put the value p of 2. What will happen? 2 square minus 2 into 2. What will it become? 4 minus 4, which is 0. That means at the value of x equal to 2, the polynomial becomes 0. So the value 2 is the 0 of polynomial for this particular polynomial. Okay. Now, suppose I put the value 3. So p of 3 would be what? 3 square minus 2 into 3. That would be 9 minus 6, that is 3. We wanted 0, but we are getting 3. That means it's not a 0 of polynomial. Now, the degree also determines the maximum possible solutions or the roots to the particular expression. So if the highest power is 3, that means there can be at the most 3 possible values that can satisfy the polynomial where the value would be coming to 0. If the highest power or exponent is 2, that means there can be at the most only 2 such values that can satisfy this entire polynomial to give the value 0. Okay, so that is why in linear equations we get only one solution. In quadratic we get 2 solutions. In cubic at the most we can get 3 solutions. Now division. Now in childhood we must have done division a lot. Okay, so let us just do a simple division and explain certain basic concepts. Okay, here divisor. What is the divisor over here? 3. The one which is dividing. Dividend is one which is getting divided. Now quotient, let us see. So 18. How many times does 18 go in 3's table? 6 times. Okay, 18. After that, there is a 7. 7 comes down. Okay, this was 0. So how many times does it go? 2. 6. Remainder is 1. So 62 is the quotient, 1 is the remainder. So what do we infer? 187 equal to 3 into 62 plus 1, that is dividend equal to divisor into quotient plus remainder. This is what we had done since childhood. Now the same thing we are going to do for algebraic expression, or rather the polynomials. Okay. First thing, whenever you are supposed to divide one polynomial with another, okay, make sure it's in a particular order. That is, if it is x plus 3x minus 1, you should rewrite it as 3x square plus x minus 1. That is rearranging them from higher power to lower. Got it? And here it would be x plus 1. Got it? So now let us learn how to divide such kind of algebraic expressions. 3x square plus x minus 1 divided by x plus 1. So 3x square, and look at this x. What should be x multiplied with so that we get 3x square? So obviously there will be a 3 involved and there will be a x. So 3x if multiplied with x will give me 3x square. Okay. Now we have one part of the quotient. So 3x into 1 is 3x. So first we are going to write this 3x square, because 3x into x will give me 3x square, and 3x into 1 will give me 3x plus 3x. So as we do, we change the sign. So this goes off, plus x minus 3x becomes overall minus 2x, and this minus 1 comes down. So what should we multiply with x to give me minus 2x? Minus 2, of course. So minus 2 into x will give me minus 2x. So minus 2x. And minus 2 into 1 will give me minus 2. Okay. Again, I'll reverse the sign. This goes off. Minus 1 plus 2. What do I get? 1. So in this case, 3x minus 2 is the quotient, x plus 1 is the divisor, 3x square plus x minus 1 is the dividend, and 1 is the remainder. So we can also write it in this format: 3x square plus x minus 1 equal to x plus 1 into 3x minus 2 plus 1. Dividend equal to divisor into quotient plus remainder. If you simplify this and add 1 to it, you would get exactly the same thing over here. Okay. So I hope you would be practicing few such algebraic division also, so that things are much more easier for you. Okay. Now this is the last portion that we are going to study in part 1. There would be a part 2 of the video also, because in one video if I keep everything it would be too long and it would be too monotonous also for all of you. Okay. So what does remainder theorem say? That if Px is divided by linear polynomial, remember this word, linear polynomial x minus a, then the remainder is Pa. Now if we try to do the long division method, the one that we did just now, then what will happen? Suppose if there is a 1 marks question that is asked that find the remainder when px is this, which is divided by x minus 1. So what would be the remainder? So for 1 marks, if you would be doing the division and all, it would take at least 2 to 3 minutes. Chances of making mistakes are very high. So the remainder theorem comes into the play. It says that if a polynomial, in this case this is that polynomial, if it is divided by a linear polynomial, then the remainder is Pa. See, x minus a, here we are putting the value as a. So what happens when it is divided by x minus 1? So x minus 1, if it is divided, if this is divided by x minus 1, so basically if it is a 0 polynomial, it would be 0. But in this case, let us see whether it is giving a remainder or not. So x will be equal to 1. This is the value that we are going to put in this particular polynomial to see if 0 comes or not. If we get a 0, that means this divides it completely, and whatever value remains, that shows that is the remainder that we would be getting. So P of 1. See, here we have x minus 1, that is why we are putting the value as 1, not minus 1. So this x to the power 4 means 1 to the power 4 plus 1 to the power 3 minus 2 into 1 square plus 1 plus 1. So 1 plus 1 minus 2 plus 1 plus 1. This would be 2 minus 2 cancels, 1 plus 1, 2. Now, if we divide the expression, this particular expression, with x minus 1, we would get remainder as 2 itself. Okay. So, if it is a 1 marks question, we would be using remainder theorem. Okay. And if it is a 3 or 4 marks question, Okay, we would definitely try to do the long division where we need to factorize things further. Okay, so that is it for today. We'll be studying the factor theorem and the ways of solving the particular expression as factors and algebraic identities also in next part. Thank you all, and if you like the video, do subscribe to it and also share with your friends who would be learning new things through it. Thank you.